You pull your phone out of your pocket, open a map, and a glowing blue dot instantly drops right on top of you. That tiny blue dot knows exactly where you are standing because of a formula you probably haven't thought about since middle school geometry. A squared plus B squared equals C squared. This theorem is the geometric bridge between a set of abstract numbers and your physical location in the real world. To figure out how your phone can track satellites orbiting the Earth at thousands of miles an hour, you have to start with a truth about flat space discovered over 4 millennia ago. It is the specific rule that allows us to convert the time signals take to travel through space into a usable distance on the ground. The formula only works for the shape on the left. If you alter that 90-degree angle, the relationship disappears. Here, the sides map into whole units, 3 on the vertical, 4 on the horizontal, and 5 on the hypotenuse, a Pythagorean triple. Ancient builders realized that if they measured out materials in these exact proportions, 3, 4, and 5, they could guarantee their corners were perfectly square. Surveyors in the Old Babylonian period were using this rule to lay out floor plans and scale city walls as early as 1800 BC. Ancient Egyptians utilized this logic to construct the precise corners of their pyramids, using ropes tied with knots spaced 3, 4, and 5 units apart. For these civilizations, this geometry was a practical tool for making massive structures stand upright and stay level. We can verify this through a geometric proof. 4 identical right triangles inside a square leave an empty center representing C squared. Sliding them to form 2 rectangles splits the empty space into squares A squared and B squared, which must equal C squared. This demonstration confirms the relationship is built into the geometry itself. As long as the angle is exactly 90 degrees, the areas will always balance. This same logic works in 3 dimensions. Computer graphics engines use the theorem to measure distances between points to render environments on your screen. But its most frequent modern use happens in the sky through a process called trilateration. To find your location, a smartphone receives signals from 3 satellites orbiting Earth. The phone measures their travel time, converting it into distances. These distances act as the hypotenuse of right triangles. By solving for the missing sides, the system calculates your precise coordinates. It is the same rule that leveled ancient temples, now functioning as the primary calculation for modern global navigation. Pythagoras likely did not invent this rule. It was discovered independently across different cultures and eras, which suggests it was a universal relationship waiting to be identified. Later, the Greeks formally codified these observations into a set of geometric proofs, providing a rigorous mathematical framework for the theorem. The core logic of the theorem even extends into modern physics. By expanding the formula to account for gravity and position, scientists use a generalized version of this relationship to measure distances through the curves of space-time. 4,000 years after it was used to align a brick wall in Babylon, the theorem remains our primary tool for measuring the distance between any 2 points in the physical world.